All right, today we are doing lesson 90. Lesson 90 is on sets. This is lesson 90 of Saxon Math Course 3. And sets, this lesson is actually going to cover a lot of the concepts we've covered earlier in the years. We were talking about the different types of numbers. So if you think back, we started the year talking about natural or counting numbers, whole numbers, integers, rational numbers, real numbers. Kind of use the analogy of the nesting dolls, right? And so natural numbers are the smallest, right? They fit inside the whole number doll. The whole number doll fits inside the integer doll, right? So on and so forth. Okay, and so we have talked when we learned that lesson, we talked about set notation and things like that. So we're going to be using a lot of that today. All right. So a set is a collection of elements. Okay, an element can be almost anything, right? So we have sets of numbers. We could have sets of people, right? Sets of shapes, sets of colors, right? A set can be almost anything, right, that I can make a group of. Anything that's a group can be a set, and the elements are the pieces or parts of that group. We list elements of a set in braces, right? So this is review. The braces are like the fanciest of the parentheses, of the inclusion symbols, okay, grouping symbols. And so the braces are on both ends of our set, right? So right now, I want you to see if you can, using set notation, write the set of whole numbers and the set of integers. Maybe pause the video or... All right, so here we go. So set of whole numbers. We'll go, we'll change color. Let's go purple. All right, so a set of whole numbers, right? Again, we need to use braces. Whole numbers are going to start with 0. We use comma to separate our elements. All right. Now, if I were to try to write the entire set of whole numbers, hopefully you realize we'd be here forever, because this is going to go on in this direction forever. It starts at 0, it goes to infinity, right? And so, to avoid being here forever, we're going to use the 3 dots. And these 3 dots are called an ellipsis. I'm going to put my brace to end. All right, so we can put this up there. An ellipsis should be review. Right, are the 3 dots. And it shows the set continues without end. Okay, so whenever I have a set that doesn't have an end, I need to use the ellipsis. Otherwise, I'm going to be in trouble when I try to write that set. Now, set of integers. All right, if you haven't, pause it. Try to write the set of integers, knowing what we know about the set of whole numbers. Okay, so we come into a similar problem with the set of integers. I'm going to use my brace to start. But this continues in both directions without end. Integers are the whole numbers, right? Or basically counting numbers and their opposites and 0. Okay, so this is going to be negative numbers, positive numbers, 0, right? No fractions. So we're going to say start with an ellipsis. We'll go -2. -1, 0, 1, 2, ellipsis, brace. That was a bad brace. All right, so again, ellipsis at both ends because this set continues in both directions without end. All right, so sets should be reviewed up to this point. We've covered this stuff previously. It's one of the first few lessons we've done. Moving on. Talking about the elements. All right, so to indicate something is an element of a set, we use this symbol. All right, it looks like a curved E. All right, so this is the first of many symbols that we're going to cover in today's lesson. Okay, so the curved E is the symbol for the word element. All right, so and over there on the left-hand side in orange, you might see in your text 5 element symbol braces integers. Okay, so what is this shorthand for? How would I read this? What is this saying to me? All right, so this is saying that 5 is an element of the set of integers. Okay, so the second one, should know, if you need to, pause it, see if you could come up with what this would be read as. This would be 0 is an element of the set of whole numbers. Okay, so the element symbol. All right, so over there in green, got a question. Which of the following is true? Select all that apply. A, B, or C. Pause it, come up with your answer. All right, so A says 1/2 is an element of the set of rational numbers. This is true. 1/2 is a rational number, and so that is an element of that set. B, 2 is an element of rational numbers. Again, true. Remember, rational numbers are any number that I can make a fraction using integers. Okay, so 2 over 1, right? 4 over 2, definitely rational. All right, so 2 is an element of that set. C, √2 is an element of the set of rational numbers. Hopefully we realize that √2 is irrational. The square root of any non-perfect square is going to be an irrational number. So C is not true, A and B are. And so you might see, right, this, the element symbol with a line through it. Okay, and so that would be, this is not an element. √2 is not an element of the set of rational numbers. All right, so another symbol there for you, the element symbol with the line through it. All right, to indicate no, this is not an element of that set. All right, going to the next slide here. Okay, some more symbols, getting into the finer points of this lesson. We have subsets, intersections, and unions. Okay, so starting with subset, top left. A subset is a set that is part of another set. Okay, so for example, here at Mater Dei, the upper school is a subset of the entire school. Right? It is part of the whole school. Okay. Lacrosse players are a subset of all sports at Mater Dei. Right? They are a smaller group of a larger group. Okay. So for subsets, we use this symbol. All right. It looks like kind of looks like a C. Now, you'll see in the text, it's going to be. It's almost like a U that's been turned on its side, okay? So it looks like a C sort of, but it kind of is more of a U shape. I'm just not great at drawing it. All right, so in the example there, right? How would I read that? Okay. Take a second. All right, so this would be read as, let's change color. We'll go, I guess we'll keep the purple, sorry. All right, so we'll go set A is a subset, right? That's what this symbol is, of set B. Okay, so that's subsets, smaller groups that are part of a larger group. Next, in green, we have intersections. All right, so an intersection is where two sets overlap. All right, so an intersection here, another modern day analogy. 7A homeroom teachers and upper school history teachers. All right, so 7A homeroom teachers, upper school history teachers. The intersection of those two sets, there's only one person in that category, right? And that is Mr. Muir. There's only one teacher who is both a 7A homeroom teacher and an upper school history teacher. Both groups have more than one person in them, right? 7A homeroom teacher, myself, Mr. Muir. Upper school history teachers, right? You got Mr. Witz in 5th grade, Mr. Tropia in 6th grade, Mr. Meert in 7th grade, Mr. Geimer in 8th grade. So when I intersect, the overlapping of those two sets has only one person that is both, a member of both, and that's Mr. Meert. So that is an example of an intersection. Okay, so in the example, how would I read that, right? So just practicing it. Oh, I'm sorry, back up. So we use the symbol that's shown there to show an intersection. Okay, so the way I can remember this, right, is that it kind of looks like an N. All right, so intersection is an N. Okay, you'll see when we get to the next one, it makes even more sense. But it's kind of like, again, it's like an upside down U, all right, which looks like a lowercase n. Okay, so in the example, how would I read that? So this is set A I guess I would say, let me back up. Probably say the intersection of set A and set B. All right, where do set A and set B intersect? Okay. All right, and then last we have union. Union is the combining of two sets. So the union of the lower school and the upper school is a set that entails the entire modern day school, right? So lower school students combined with upper school students make for the entire school. So this is a union. It's the combining of two sets. To show a union, right, we use the symbol that looks like a U, all right? So the U is for union. The N is for intersection. I don't have a great one for C, subset, all right? But again, these are all, you'll see in the text, much more shaped like a U, just turned on its side, turned upside down, or actually like a U. All right, so union, combining of two sets to make one large set. Lower school and upper school together make the entire school. All right, so in red, the set, the union, this would be read as the union of sets A and B. All right. So subset, intersection, union. Next, some more symbols. Okay, so to make our lives a little bit easier, all right, we have some symbols for the different types of numbers. Okay, so we have symbols. N is for natural or counting, which may be better if you just remember as natural. All right, so an N is for the natural numbers. Z is for integers. Okay, Q is for rational. All right, and the book explains that they used Q because rational numbers are numbers that you can make a fraction using integers, right? And a fraction is basically a division problem in disguise, and so Q stands for quotient. The Z for integers, I'm not exactly sure. I imagine that I couldn't be used because some issues with I. And then R for real. Okay, so natural numbers 1, 2, 3, 4. Integers, whole numbers and their opposites. Rational numbers, numbers that can be made into a fraction using integers only. And then real numbers, right? Any number that you can place on a number line. All right, so that includes both rational and irrational. All right, so no symbol here for irrational numbers, no symbol here for whole numbers, but natural, integers, rational, and real. Okay, so outside of those, we just review the other symbols that we've covered so far. We have the braces that indicate we're talking about sets. We have the E, the curvy E that tells us that this is an element. We have the sideways U or the C that is the subset, the N for intersection, the U for union, and one that we haven't covered yet, but we're going to, is the 0 with the line through it, which stands for an empty set. Okay, so there may be times where you maybe have to find the intersection of two groups and there's nobody in there, right? For example, the intersection of 7A homeroom teachers and baseball coaches, right? There's nobody in that set. There's no overlap. There's no baseball coach that's also a 7A homeroom teacher. There's no 7A homeroom teacher that's also a baseball coach. So that would be an empty set. All right, so some symbols for you. All right, 2 slides left. Okay, so some examples here. So the book, and it's good practice to go over, the book uses Venn diagrams a lot, and you're going to be asked to make Venn diagrams. So a Venn diagram is a diagram using circles to show either a union, an intersection, right, a subset. Okay, so we take the 2 sets and we visualize them as circles, right? And then depending on what I'm trying to find, see where the overlap and union or subset lies. Okay, so let's try a couple. So for both of these examples, we're trying to find the intersection of A and B. Okay, so we're told in the first example that A, the set A, is consists of the elements 1, 2, and 3. That's it. B, I probably should do maybe this, is the set of N, which is natural numbers. Okay, so the counting numbers. All right, so we're trying to find the intersection of these 2. Okay, well, so let's make a circle for 1, 2, and 3. Right? And then we know that natural numbers, this is kind of back to the nesting doll analogy, natural numbers include 1, 2, and 3, right? So natural numbers is a much bigger group, okay? So and it includes 1, 2, and 3. So my Venn diagram might look something like this, right? Okay, and I can't do it the other way, right? Because not all the natural numbers fit into the group of 1, 2, and 3. 1, 2, and 3 is a very small group. All right, so it fits inside. So it's actually a subset of natural numbers. Okay. The second one, again, trying to find the intersection of A and B. Okay, so I have 2, 4, and 6. and 1, 3, and 5. Those are my elements. I'm trying to find the intersection where these two sets overlap. Well, so here's my Venn diagram essentially, right? Trying to see if this is A, this is 2, 4, and 6. And this is B, this is 1, 3, and 5. They don't share anything in common. The two sets have no numbers that are in common. So there's nothing in here. There's nothing in this overlap. So this would be an empty set. Okay? So those are some examples of Venn diagrams, right? There may be some examples in your practice set. In fact, I know there are, where when you make a diagram like this, there are going to be numbers that are in common. So you would put those in the center, the two overlapping pieces, the one overlapping piece. Okay? All right. Last slide. Another example. So here we're trying to find the intersection of A and B, and then also the union of A and B. Okay, so A, we're told, is a set that consists of 1, 2, 3, and 4. B, we're told, is a set that consists of 2, 4, 6, and 8. Okay, so first let's try to find the intersection, right? And if we want, we could make the Venn diagram. Okay, so we know we have 1, 2, 3, and 4. That's a bad. Let's make this a little larger. All right, so here we go. 1, 2, 3, and 4. So this is for the intersection. 2, 4, 6, and 8. Okay, so what do these two sets have in common? Well, they both have a 2 and a 4. So I may say, let's just change this a little bit and go like this. We'll put the 2 and the 4 in here to show that it's part of both groups. So for the intersection of A and B, I would say that that is equal to the set of 2 and 4. Okay, now the union, right? The union, I'm just going to combine everything. So for the union, oops, not an actual U. For the union of A and B, I'm just going to put both groups together. Okay, so it's going to be the set of 1, 2, 3, 4. I don't need to repeat anything, all right, just to show. I'm not going to repeat it. They're in both groups. So if there's 2 and 4, I'm just going to write them once. So 1, 2, 3, 4, 6, and 8. So that's just what happens when I stick both those elements, the elements of both groups together. I get a set that looks like that. 1, 2, 3, 4, 6, 8. And that's it. That's sets. Okay, so a lot of symbols to know, right? Other than that, should be some review, right? Using the Venn diagrams can be helpful when you're kind of stuck to visualize where the overlap is or where the combining of the two groups is. But other than that, that's it. That's all I got.